dealing with number 3s today, right? And there is one paper, which is this exact paper, January 2026, that has transformations in number 9. So this is the only paper that I would actually be doing in number 9, part A. When a shape makes a full 360-degree rotation, it will obviously look back the same way. So we're talking about any rotation it could make, right? And still look the same. That'll be a rotational symmetry. This one we're looking at here would have a rotational symmetry of all the sides, right? So it'll be 8. Because anyhow you turn this, it will look the same, right? So A, B, C, D, E, F, G, H is a regular octagon, right? By the way, the word regular, the same, or with the same, I shall say with the same measurements, right? If this is a regular octagon, it means all these sides are proper. Every bad boy here is equal, and all the angles are equal also, right? All these bad boys are the same. So that's something I know about this shape before even starting the question, right? So with one of its internal angles marked G, as shown in the diagram below, right? Complete the statement below in relation to the diagram shown above. The regular octagon has how many lines of symmetry, right? When I draw it out, it is actually 4 on the vertices. Remember, every 2 vertices gives you 1. 1, right? So it's like 8 divided by 2, which will give you 4 lines of symmetry. And then you have 4 lines of symmetry through the center of each line also. So this is one here. You have our next one here. Boom. Right, then you have our next one here. Oh, they're catching it there. Our next one there. Boom. And then you have the last one here. 4. Everybody good there? Yes. So that would be 8. 8 lines of symmetry. Okay? 8 lines of symmetry. So catch that good. And then, say that again, bro. So we check any rotational symmetry just to make sure we're not wrong also, right? So you check it here, 1. Then you go here, 2. Then you go here, 3. Then you go here, 4. Then you go here, 5. Then you go here, 6. And then you go here, 7. And you come back home, 8, right? So 8 in total, right? Them sugar demons. Cooks and good. Hey, brother, I ain't good right now, nah? Let go. Sum of all interior angles, right? Sum of all interior angles, and I want to put in any polygon with 3 sides, with 3 sides or more. Or more. Right? So we go in. When n is the number of sides, right? Sum of interior angles is equal to, open bracket, n minus 2, close bracket, multiplied by 180 degrees. 4. So if a quadrilateral has 4 sides, 4 minus 2 would be 2 multiplied by 180 would be 360 degrees would be the sum of all the interior angles in a quadrilateral, any quadrilateral, as a matter of fact.
The sum of all and then divided by the number of angles have.
Yeah, let's go. That is correct, right? So in order to calculate the value of angle G, 2 things I'm going to pay particular attention to. I'm going to pay attention to this word here, regular, and octagon. Because octagon means it has 8 sides, which means 8 angles, right? And regular means all these sides and all these angles are equal. That word regular means that, right? So there we go. So the first thing I need to find here would what would be the sum of all the angles. So I'm going to put here when n is equal to, how many sides we have? 8. The sum of all, or let's see how much time write it again. I was telling you, sharing this week. It's a whole set of laziness going on. Laziness is you see me. I just write some of all interior angles, and I come and write it again. You know what laziness will tell you to do? Jonas. What laziness will tell you to do? Hey, Jonas. Hey, Jonas. Shania sing. What laziness will tell you? Hey, Shania sing. I writing over the same thing I just write here. What laziness will tell you? Shania sing.
Not to write it back.
Because you don't have it in your bookend. Why are you writing it again? Why? That's what laziness will tell you, but you know why you're writing it? Because you want it to stick. Supposed to write this about 10 times. Sum of all interior angles would be equal to n minus 2 multiplied by 180. All you overcome laziness. That is what education preparing you to do, to overcome laziness. So we go in. Talk to me. This will be 8 minus 2 multiplied by 180. What's the sum of all interior angles?
1,080.
Therefore, G is equal to 1080 divided by how many angles do we have? 8. And this will be equal to? Come, Kyle. 135. Talk done. Let me go. So similar, I want you all to know this information before we go to the other part of the question, right? Similar triangles are triangles that have the same shape and same corresponding angles, but not necessarily the same sides, right? So the angles will always be the same, chiffon, right? The angles will be the same, but the sides will be proportional, right? What that means is that if like we denote a right angle triangle, and one hypotenuse is like, say, 3, and the next hypotenuse is unknown, and they tell you like the ratio is like 3. So it's like similar to enlargement. And for enlargement, if one side is 3, the next side in the enlarged image would have been 9. If the scale factor is 3, right? So you multiply 3 by 3, but that holds for all other sides, right? So that is the information you are given there. So we're going to try this question now. Let's go. So this is part B. They said the diagram below shows two similar right-angled triangles. So they said they are right-angled triangles. We were given that information. So that means here is 90, and here would be 90 also. All right. Now they said drawn from a common vertex V. So both of them come off V. Right. So I could separate this triangle here, this baby triangle here. All right. I could separate this. So we have V, we have Z, and we have Y, right? This is 90 degrees, this is 5, this is 7 centimeters, right? So we'll work for this one here, we work with the outer one. Boom, right? Bang, and bang, right? This is what we're working with here, right? Now, in this triangle, right, they said lines VY is 5, ZY is 7, okay, and WX is 20. Now, if this line corresponds, which is VY, corresponds to WX, it means that my scale factor here is 7. How did I get that? I did 28 divided by, not 7, sorry, 4. I did 28 divided by 7 to get 4. So the first part is to calculate the length of YX. YX is this little piece here. That dog food, I know. Look how much dog food there is, eh? This is B part 1. The first thing I'm going to calculate will be my scale factor. That would be 28 divided by 7, which gives you 4, right? No. Each side is separated by the scale factor of 4, meaning that if he has 7, 7 multiplied by 4 will give you 28. Then this baby one here is 5, which is VY. So what would VX be, which is the longer line? So VX, I'm going to write down underneath here, VX. So therefore, VX would be equal to 5 multiplied by 4, which will give me centimeters, right? So this whole thing is 20, right? Come on, man. Look at how easy CXC give. That's why when when us teachers see an exam and say it easy, it's questions like this we're talking about. Right? So let me go. So this implies that what they are looking for, which is yx, is equal to yx is equal to 20 minus 5, because it's going to be the full 20, which is vx, minus this little piece here, which is 5 centimeters, to remain with yx. Everybody good there? So this will give me 15 centimeters. Proper. Now determine the magnitude of angle WVX. I'll do WVX up here. How clear is that? What are we using? Trigonometric ratios. But which one are we using? Tan. Because we have what? What 7 is? My what?
You have the opposite and the adjacent.
And the adjacent. How we know this is adjacent is because we know here is my hypotenuse. Once you can identify your opposite and your hypotenuse, the other side will simply be our adjacent. So let me work. We work with opposite and adjacent, so we work with TOA. Right? Tan of theta is equal to... Say that again, bro?
How come you using VZY?
Yeah, boy, I called the wrong one there. Hold on. No. It's this one here, bro. This one here we're looking for. This one up here. The wrong one I call there. Hold on. Wait. Right. So this one is V. Right. So I watching it here, right? That was my problem. I come down here and I watch here, but I didn't see no W. So I don't know why I just put this one. But V, watch it, V to W to X is this bad boy up here, which would actually be this angle. Why? Who can tell me why it would be this angle? Because they are what? Corresponding angles. They are corresponding angles. So if here's theta, here's theta. So it's this angle we're looking for. So this would be different because... Go ahead there, Kyle.
I thought you was doing that just to show you it was corresponding, but that would have been too much working.
Yeah, correct. That would have been too much working. Right? So let go. So we want to find this angle up here. So we're going with opposite is now this. This is opposite. And what 7 will be now? 7 will be my adjacent. Right? So I just want to put a little note here. I want to put that VZY is corresponding to VWX. Alright? So once I have VZY, I have VWX, right? So we're going to use same tan of theta would be equal to opposite all over adjacent. So theta is unknown. So tan of theta would be equal to, what is my opposite again?
20.
Nah. Well, yeah, we could use that one time, you know. We could use that. I now realize we had the 20 there. Yeah, let's use the big one time. You get the same thing, you know. You get the same thing. Right? It's the same angle. So if I use 5 and 7, you know, I get the same answer.
Yeah, you get the same angle.
You get the same angle, right?
But they say therefore the two angles are equal because
they are corresponding. When tan moving by itself, what tan becomes?
tan inverse.
So somebody work on this for me.
35.5.
35.5 degrees. Right? That's our bad boy up there. Is that everything they are? So therefore, VWX, which is what they're asking for, VWX is equal to 35.5 degrees. right? All right, let go. I just want to do this question here on this worksheet, right? Well, on this paper because it's similar, right? So we're going. Let's see the question asking. The diagram below shows quadrilaterals O, M, and N. Quadrilaterals M and N are images of quadrilateral O. So O is the object. These two are the images, right? After it undergoes two different transformations. Now it's clear to see, it's clear like day. This here is a what? Enlargement, and this one will be a rotation, right? Okay, so let me go. Describe fully the single transformation that maps quadrilateral O onto M. So if we go and map O onto N, some things we don't know. We have no idea what the scale factor is. We have no idea what the center of rotation are. Is N? No, M. O onto M first, right? O onto M. So we have to find center of rotation. We have to find the scale factor, right? So let's see if we can find the scale factor first. Is there any outright line that we could measure? I'm seeing this is a diagonal, right? You're seeing that this is a diagonal. So this line, if this is a square, right? What is diagonal will be? I was just watching to see if any other line could have lined up, right? So this is 2, sorry, this is 2, and this is 1. So my scale factor would be a scale factor of 2, right? So that's my scale factor. I know I'm working with 2 for the scale factor. So when I'm writing out my full description, I would put in scale factor. So let me just put the information here before we even write it, okay? This was number 9A part 1. 9A part 1, right? So let's put in scale factor is 2. Okay? Now, we need to find the center of rotation, right? So I'm doing this, not rotation, enlargement. I'm doing the center of enlargement here, and I'll do the rotation on my, on this up here, right? I'll do the rotation here. So let go, center of enlargement, you want to connect at least 2 of the corresponding points, right? So we could connect this one with this one down here. And of course, I'm not getting the autocorrect. Ramon, you seen it? No. Connect 2 corresponding points and extend the line, right? When you extend the line, you get the center of enlargement to be right here. Now you can't draw it all, but from the time you draw 2, you will see that it lines up, right? So I just connecting the rest to show you all how it would line up here. Boom. So my center of enlargement would be 1 on the x comma what?
-1.
-1, right? This is the center of enlargement. Everybody good there? So my center of enlargement is 1 comma -1. The question asks us to describe fully, right? So when you put in your description, you must have these 2 things in it, right? So the transformation is an enlargement of scale factor 2 with center of, come on, don't give up now, don't give up, of enlargement 1 comma -1, right? Describe fully, part 2, describe fully the single transformation that maps quadrilateral O onto quadrilateral N. So if you look at this, you're seeing it's not a reflection, it's not a slide, it's not an enlargement. So it is obviously a rotation, right? So this bad boy starting here and coming here. Now, this rotation is actually, I'm not watching it, it is 180 degrees, right? Which is the easiest rotation to work with, right? You don't have to do no you don't have to use no compass, right? You don't have to use no protractor, right? You could just connect all the corresponding points and you'll get the center of rotation, and you could see clearly that it is a rotation of 180 degrees, right? So we'll still go here. Actually, let me just do it here. I'll do it in red for the second one. So you're trying to find the center of rotation. Now, this point here would be what point when this comes all the way around here? Would it be 1, 2, 3, or 4? Which number? 1, 2, 3, or 4? Being able to see that is the only way I'll get this. When this rotates, when it's coming here, you sure it's not this one down here? Nah, it's this one here. You have to be able to see that. So let's connect those 2 points. Christiana, take it there. Boom. This one here will be which one? This one up here will be which one? 3? 3 is this one, eh? Because I count them 1, 2, 3. So this one up here will be 3, you sure? That would be this one here. That would be 4. So this one rotates, boom, to come here. Everybody seen it? So let's draw that line. You don't have to draw the arrows, eh? You don't have to draw the arrows. That one thing I show about. Let me move them arrows, eh? Next thing people feel we have to draw them arrows. You don't need to draw those arrows, okay? So then we come in here now. Which one is this one? 1, 2. Is it 1, 2, 3, or 4? This coordinate here. Is it 1, 2, 3, or 4? And let's count any points. 3 is this one here. So this would be 3, you sure? It will be this one here, 2. Right? So this point rotates this way. So once you're able to see what points it moves to, I get the autocorrect here. Hold on. Delete. Once you see the line it moves to, you're good to go. Or the coordinate it moves to. And this one will obviously be the last one there. Everybody good there? What is my center of rotation?
0.
0? Just 0? So this is my center of rotation. Right? Everybody good there? So center of rotation. Let me write it down, right? And everybody can obviously see now the way to figure out if this is a center of rotation is supposed to put your protractor here and just measure how much degrees this straight line would be, right? But it's a straight line, so it'll be 180 degrees. Another thing, right? So 3 things you have to actually know when you're doing a rotation, right? Number 1 will be the center of rotation, which will be 0, 0. The direction. The direction would be clockwise or, once it's 180, clockwise or anti-clockwise, right? So let's put clockwise. And you also need to know the angle. What's the angle? So the angle will be 180 degrees. So we have all the ammunition that is needed to write my description, right? We have all the ammunition that is needed to write my description. So let's start it right. The transformation is is a rotation, of 180 degrees about the origin, right? Why I use the words origin is because the origin is 0, 0 in a clockwise direction. Right? Everybody good here? So let me run this one time because I'll have to go on my app, right? So, using a ruler, a pencil, and a pair of compasses, construct triangle PQR such that write down PQ is equal to 9. Let's write down PQ is 9 centimeters. Online, write down that. Kyle, write down that. Kishona, write down that, right? Write QPR is 60 degrees, write down that. And then write down PR is 12 centimeters. I'm going to start with PR as is the longest one, right? PR is what I'm going to start with, right? PR.
You think you should start with PQ?
Yeah, the next one, let's go. Yeah, no, let's go up here. Because I see it had a fit in the space, right? So let me go. So, bye-bye. We can move this because we didn't really need to use this, right? Right, I can move this. Boom. So there you go. Start with, I'm gonna give all you a little visual on how this thing will be. So don't go close to the top of the page. Come down. So if you can draw at the base here, draw at the base, right? So what was the first line? The first line was what?
PQ. That was 9 centimeters.
Right. So let me start with it's PQ or QP?
PQ.
Right, PQ, right? I go down my pen here, buddy. So number one, before we even start the show, make sure that the two tips of your compass are lined up, right? Line up the two tips of your compass, okay? Hold on, Hi. That's number one. So once these 2 points are lined up, I want to make videos with all these things, boy. Line up these 2 points because this is very important. If you do this so, if you line up this ship it so, you're failing, right? Make sure the point of your compass and the point of your pencil must be lined up, right? Make sure that you tighten your compass. You see this screw here? Get a Phillips screwdriver or a flathead, whatever it is, make sure that tight, right? Then, if we started with, what's the first one? Right. So you go to your compass and you're going to open this to 9 centimeters, right? This is what you're doing. Open it to 9 centimeters. Everybody good there? 9. Make sure it is 9 centimeters. You all see now the ruler. Open it to 9 centimeters, right? So once you do that now, come on, let go. Once you do that, I can open mine. So why I did that demonstration is because when I open mine, I am seeing the actual 9 centimeters at the bottom there. You'll see how I could open mine to 9 centimeters. Watch it. Look, you see 9 centimeters, right? I'm going to put the pointy end or the sharp end on the point that I established, which is P. And then I'm going to make an arc on this side. Boom. Everybody good there? That's step number one. We're trying to draw a line that measures 9 centimeters. Then you're going to pull the people line. You're going to pull a line from here straight across to stop at that line. And establish this point here as the point what? What this point will be? Jesus Christ. What's this point? Was it vertex here? Pure Q. And you could label this 9 centimeters 1 time. Right? Everybody good there? So if we cooking or if we the stove going through. Ramo. Let me talk to you. So I'll write it above here. Right? I'll write it above here. PQ was 9 centimeters. I shouldn't write here no. Because I'm going to draw a long line coming up here. I'm not sure which side it'll be on.
It's going to be
On the left or on the right?
it's going to be on Q because the
Okay.
angle P is 60.
What is the angle?
QP
60 degrees.
Q, but what is this? Q to P to R, 60 degrees. And what was the last thing?
PR is equal to 12 centimeters. Okay, then,
PR is equal to 12.
12 centimeters going up through the angle.
Up. Right. So let me open your compass to 12. Or you can reach 12? Right. So you all have to measure it on your ruler. I have up here that I can just open it and I will see that it's open to 12 centimeters, right? And I'm going on the line, well, the vertex that is in the middle. I'm going on P. This is where my angle is located, right? On P. So I'm coming here. Actually, we could do the 12, better we do the 12 centimeters one time, right? Now we won't be able to know. That the last thing I'll measure. Here, I don't open out this thing here. So this palm mark is 60 degrees. 60 degrees will be somewhere around here. So you can palm mark here if you want. So you know that when you draw your final P to R, you're stopping. Nah, this all right. Hold on. Oh, this shows 60 degrees? All right. Well, 60 degrees. So you're drawing a line from P going to R, and it will measure 12 centimeters. So you're stopping by this arc, right? Right. Yeah. So what's something? You have to make this smaller now because we're going to construct 60 degrees. Okay? So remember, to construct 60 degrees, you're going between halfway of the line and the full length of the line, halfway, right? Some people, let's go straight here and measure it, but I say go half, well, a little more than halfway between the line. So you're going to put an arc here. Let me put this in red. You're going to put an arc here, boom. Then you're going to put an arc around where 60 degrees would be. 60 degrees. Now, why we put an arc is because you have enough space to account for wherever it drops, right? Lift this sharp end. Place this sharp end by the point you just created by where the arc and the initial line meet. So you're seeing where my two arcs are going to intersect now. So that's why you have to have a full arc. It's because you don't know if it'll drop here, you don't know if it'll drop down here. Now, anytime you do this and you see that you're not getting nothing, say it not on the arc, you have to go back here and extend the initial arc. You'll have to go back here and you will have to extend this arc if you're outside the range. Right, Chiffon? Yes. Okay, you'll have to extend that arc. So we're going to know 60 degrees there. That is 60 degrees. A line from here going through there is 60 degrees. And I want to show you something now. What's something? When I go to draw my 12 centimeters line, what's something? This is how the margin of error is. Right? Right, watch it. 12 centimeters, right? But you see, and you see I know the arc there? Watch. I'd make the arc a little longer. So I'd go back here now, put this here, open this arc where this compass to 12 centimeters, which will drop me right there. Boom. Right. And I have to extend this bad boy here. Wait. Yeah, I'll extend that bad boy. Because you need to draw a line that touching that. Right, Christianat? We good there, Christianat? We have to be good there, brother. Have to win, Christian. Come here to lose, There we go. Somebody have a question? Go ahead.
So when you draw the 12 centimeter out, here you draw a line towards the dot.
Right, so you're gonna draw a line. So I could just line up I lining up P and this point here, bro. This point I just created there. That is 60 degrees. Right, so let me go. 60, bang, bang. Right, just line up them 2 points, please, and you're stopping. You're stopping here. You're stopping there, a little off, but that's okay. Right, you're stopping there. Now I'll find a real off, David. I'll find a real off. I want to draw over this line. Alright, there you go. You join over this line. Alright, a little better. Stop there, that's 12.
So, question, by the 9 centimeters, you're at 9.
This here?
Yeah,
I put my sharpen here. Right, boom. And I open my compass a little more than halfway between the lines. So halfway of the line is about here. So a little more than halfway be about here.
So you could average that?
Yeah, it's just average. So you make a slash here or an arc here, and then you make another arc up here. So let's label this as 12 centimeters, please. And it's a triangle we're trying to draw, so you need to complete it. What is this versus C up here? What's this versus C up here? I ain't know here. What's this versus C up here? What's this point up here? R. And how much degrees this is?
60.
Can we complete our triangle, please? Because that's what the question asks us to do, to construct a triangle. Right? Let me construct the people triangle. Please and thanks. Please and thanks. Okay? Come on, have fun, boy. You win now, boy.
That curve already.
Which this arc up here, you extend. So on your ruler, you open your compass to 12 centimeters. You put the sharp end on P and you make an arc. That'll be where 12 centimeters stops, right? So this here is my triangle. So this question is basically the diagram below shows two quadrilaters R and S. S is the image of R under the transformation, right? So it is clearly a what? Enlargement. So we need to figure out the scale factor and the center of, not rotation, is not rotation, center of enlargement, right? So we could do that right here. Okay? What's the scale factor? Well, how much centimeters this is here? This is 3 centimeters, right? And what this one underneath here is?
6.
So, therefore, my scale factor will be what? 6 divided by 3, which is 2. Talk done. That's my scale factor, right? Center of rotation. Let me do it in red so y'all can see it, right? Or y'all should be doing that for me by meanwhile. Center of enlargement, sorry, right? Y'all do your center of enlargement quickly, please. Quickly. Kyle, you should have that done already. Extend it, connect corresponding points and extend it. Like I gotta draw this over. Hold on. I don't see the center of enlargement gonna be right there. Christian Hart, you drawn it? And do not halfway anything this late hour. It cannot be halfway anything. Laziness is what we fighting here now. My greatest battle is with laziness, you know. Trying to figure out where the center of enlargement is, but is it here? That's let me draw next one now. Then they are told. Well, again. Alright, it's that.
Come on, someone.
Yeah, it's looking like that to me. Now, from the time I draw 2 of them, you will get it, right?
The really good thing is,
I pray that fire could lighten all your heart, boy. We're just telling yourself, I have to win, boy. Have to figure this out, boy. I'm not leaving this desk until I figure out this. And that's the kind of that's why all these down to fast food restaurants want people with education, because there's a set of lazy people coming in the institution. Set of lazy people. This is my center of enlargement. Right?
yeah.
Right. Let me write the people description now. Go ahead. What's the question? So it is an enlargement, right? So describe fully the single transformation that maps R onto S. The single, write it out, please. Transformation is an enlargement. Why I keep leaving on my in enlargement of scale factor. What scale factor was 2?
Yeah.
with center 3,7, right?
3,7.
Proper. On the same grid above, they wanted to draw the quadrilateral R when it is translated by the vector -4, 5, right? Now, if I deal with -4 and 5, the top number signifies movement to the left or right. Okay? So because it's negative, you're going to the left. And this one will be movement up or down. Because it's positive, we're going up. Right? And then they said, okay, they have some 180-degree rotation, right? So let me deal with the translation first, and then we'll deal with the rotation of 180 degrees, right? Go. So you're supposed to actually translate every single point. But once you translate one point, remember when you translate an object and image, it don't shift, it don't turn sideways, it don't turn. What do you mean?
They give you a letter to label it out.
Oh yeah, oh is the letter you asked me for. Name the image T. So let me go. We go in 4 to the left, and we go in how much? 5 up.
Yeah.
So we go in 4 to the left. 1, 2, 3, 4. So we here, right? This point on top is here. And then this same point going 5 up. So you're going 1, 2, 3, 4, 5. So this point at the top here is here. You could build the whole image of that one point. So you know this point down here is 3 centimeters down. So you go 1, 2, 3. You're going 3 centimeters to the left. 1, 2, 3. Because that translation doesn't twist or turn. It looks the same, right? Then you're going 1 up and diagonally here. So let me complete the image. So this is 1, 2. Oh my, let's do that. Alright. Let go. Wait, boy, everything's select there, boy. I just want to fix this one. And we label it as T, right? So the last thing they want us to do is to draw the image of the quadrilateral R when it is rotated at 180 degrees about the origin. Name the image M. Now, there are two ways you can go about this, right? You can, each point, you can apply the transformation matrix for rotation to it, right? The transformation matrix for rotation, you can see it above here now. So what's something? This here is 1, 1. When you rotate it over here, it becomes -1, -1. This is 1 and 2. When you rotate it here, it will be negative. It become -1 on the x, -2 on the y. Everybody seen that? Then this point here is 4, 4. It will be -4, -4. Right? So the rotational matrix of 180 degrees would be -1, 0, 0, -1, right? So it's like you're making all the coordinates negative. Okay? So we go in. And the top here will be what? This is -4, 4. This would be -4, -1. Right? Everybody good there? A rotation of 180 degrees, right? So let me draw it here. Boom. Bang. Alright, go look at the idea. Alright? Then you come down here, bang. Then you come here, bang. Alright? And this, what we naming this one? M. But I still want to show you all how I got the coordinates, right? So if I apply this to every single point, you're writing these points in vector form, right? So 1, 1. So the first coordinate was 1, 1. So this maps onto is like row by column. So this will be -1 plus 0. And underneath here will be 0 plus -1. Right? That's what you get there. Then the next one, they probably doing something outside. Same -1, 0, 0, -1 would apply to, what was the second coordinate? 1, comma 2. 1 on the x, 2 on the y, right? 1 on the x, 2 on the y. This maps onto row by column. For those who not seen it, row by column will be -1 multiplied by 1, which is -1, plus 0 by 2 would be 0, right? And then row by column would be 0 by 1 is 0, plus -1 by 2 would be -2. So this will be equal to -1 and -2. So you're applying this matrix to all these points, right? And you will get, I think the next one was 4, 4. This will be -4, -4. And the last one was, so this will be 4, 4, 1 is the last one. Somebody else saying something online?
Cycling number all and transformation matrices.
Yeah, boy, them matrices and them. You gotta be practical with it, boy, bro. So that's where, so we on to January 2025, number 3. They said the diagram below shows a regular hexagon LMNOPQ, whose side is 8 centimeters, right? So one length here is 8 centimeters. They use the main word that would help us for the, well, to solve this question. What is the word? What is the word we're looking at? Regular. So a regular hexagon means that all these bad boys are the same, right? So if all the sides are the same, what does that say about all the angles? Right. So if I want the sum of the interior angles, or angles, what would be the formula for the sum of the?
-2 by 180.
I'm really proud of you, but I hear real people answering, but that's a good sign. Right? So n would be the amount of sides in my polygon, right? So this is 6. 6 minus 2 multiplied by 18. What would be the sum of all these sides on the inside here? 720?
720, I guess 720.
Proper. So this will be 720 degrees is the sum. So therefore, angle PQL would be equal to 720 divided by what?
Divided by 6. You'll get
Divide by 6.
Alright, and you'll get the 120?
Yeah, sure.
Yes.
Alright, so divide 720 divided by 6, which gives you 120 degrees shown. Right? We ain't sticking, we moving one time. That's all. Somebody. So the vertices of a rectangle WXZ, sorry, Y and Z touch the sides PQ, QL, MN, and NO of the hexagon, the same hexagon from part A. So if it touches the or they didn't say if it touches it at the midpoint. So Z, Y, and WX are parallel to LM and PQ and PO, sorry, right? So all these bad boys are parallel here. Calculate the value of angle LWX. So I know that here is 120. I just work out that 120 degrees. They want to find LWX. LWX is this angle here, right? So here's 120. Up here's 122.
Yeah.
Yeah, like
So-
if I go co-interior angles.
Co-interior angles add up to 180. What kind of easy question is this, boy? So LWX is equal to 180 minus 120, which will give me how much degrees?
60.
This is not no reasons question, so that question done. 2 marks in the bag, right? I should have put, you know what I should put? I should put, because I've seen 2 marks. So I want to put when L M is equal to 120 degrees. So I'm just showing them what I used for that working, right? Proper. I'll do this one time, right? This is part B. In the following parts, show all your construction lines where required. The field of a sports club is in the shape of a quadrilateral RSTU. This is the field here. A scale drawing of this field is shown below, meaning that if I measure them angles and thing, wherever it is, right? So a lamppost is to be erected on the field at the point L. So you're going to put up at the point L. Okay, you don't have a point L here. Right, there we go. So the floodlights can be installed. The point L should be located in such a way that L lies on the perpendicular bisector of UR. UR, perpendicular bisector of UR, right? So bisector means it halfway, guys. So that means it's supposed to have a line here, and this is like a tower, right? I would have to construct it, but that's basically where tower goes. Let me see what they want. Is located in a way such a right, and angle LST equals 30 degrees. L, because L up here, L, boy, I put 4, boy. L to S to T is 30 degrees. So that's L to S to T is 30. Hold on, All right. L to S to T is 30 degrees, right? So let me see what they want us to construct. All right. So forget what I had here before, right? This is what you need to do. The first thing you're going to do is you're going to bisect this line here. So here what I'll do, I'm going to cut this and put it on my app, right? So let me cut this bad boy, boom. And we go in here. So y'all get out your protractor, your compass, all these things, please. All right. So we're going to put this here. All right. So we're going to bisect this line first, right? UR. I think I want to drop this a little bit. Hold on. All right. So this is how you are going to bisect a line, right? You're going to put your sharp end here. Bisect means to cut in what? Anybody? What does bisect mean? Half, right? So to cut in half, I'm just going to go a little beyond half. Half will be somewhere here, so I'm going to a little beyond half. And I'm going to draw a line in such a way that they're going to start from the top here, go down, and they're going to come around this side here. Right? And you're not adjusting your compass. You're coming on this point now. And you are going to construct another arc coming down here. And the two arcs must intersect above and below. I'm going to draw a straight line through this now, right? Straight through this bad boy, we're good. This here is the perpendicular bisector of UR. So I'm going to draw a line coming straight down. Right? So this is the first thing we're going to do. Right? Now hear what they're saying next, right? I did this first thing here. Hear what they're saying next. This question was a little technical. Wait, wrong one. Right. Next, they said the point L should be located in such a way that L lies on the perpendicular bisector of the line UR. So L is going to be somewhere on this line, right? But they said wherever L is, L to S to T is going to form 30 degrees, right?
At 30 degree angle.
Right. So here what I'm going to do now. I'm going to construct a 60-degree angle here and then bisect that 60-degree angle, right? So to draw a 60-degree angle, we're talking about T to S to 60 degrees, right? You go a little beyond where halfway of TS is. I'm going to do this in a different color so that you all see clearly. So I'm going to draw a line here. So boom, coming up to where I think 30 degrees would be. Then with the same distance, I'm going to put this sharp point here, put another arc up here, and then I'm going to put an arc over here where I estimate that 30 degrees would be. 30 degrees looking like it would be somewhere in between here. Then I'm going to put my sharp end up here, and I must draw another line so that, well, another arc so that these two arcs intersect. So that there is a 30-degree angle. I'm going to construct it now. I'm going to draw it. All right, so there we go. So I'm going from S to line up with this here, which should be 30 degrees, right? This is more looking like it, right? Boom. All right, so we go in. I join it in red. Bang, right? A little off, eh? So this here would be 30 degrees. And then where the perpendicular bisector of UR and this line meet is where T would be located. This here would be my T. Okay? Everybody good there? What the tower is? The tower is not T, the tower is L. Alright, so this is supposed to be L. This here is supposed to be L. Let me erase this. I don't know where I get T from, right? Right, this tower is supposed to be L. L. L is here, right? So what I did next, so let me hear you. A vertical pole, this is 2024 June, right? A vertical flagpole FP stands on horizontal ground and is held by two ropes PG and PR, as shown in the diagram below. So this is a pole in the middle here, and like two pieces of two ropes holding them together, well, holding it up in place, right? So PG is 18, FR is 9.7, and angle FGP is 38 degrees, right? Calculate the height of the flagpole FP. So what are we looking for here?
Opposite.
The height.
And what do we have? We're looking for opposite, and what do we have?
You have hypotenuse.
So which formula, which one of the trigonometric ratios uses opposite and hypotenuse sign? Proper. So sine theta is equal to opposites over hypotenuse, right? Opposites over hypotenuse, right? So what is theta in this case? Come on, speak it out.
38.
Opposite would be FP. Everybody agrees? Opposite
Yeah.
would be FP over my hypotenuse, which is
18.
carry 18 here. What are we doing with it?
Multiply.
So therefore, FP would be equal to 18 multiplied by sine 38. FP is equal to
11.1 meters.
proper. Somebody second that, please.
Yes, sir.
Yes, sir.
Next, they want us to find PR, the length of one piece of rope used to hold the flagpole, right? PR is on the side. So, and we just found here.
Yeah.
What I like about this question is it tested trigonometric ratios followed by what we're using here now? Pythagoras theorem, because here's 90 degrees also, right? So this is my,
Hypotenuse.
so A squared is equal to B squared plus C squared, where A is the hypotenuse, right? So my hypotenuse is represented by PR is equal to, what's B? What do I call B?
9.7.
9.7, right? 9.7 squared plus 11.1 squared. PR would be equal to the square root of
216.8986529.
89865. Let me just go there. Alright? PR would be equal to what?
14.7 meters.
Yes, sir.
Proper? In the diagram below, PR is parallel to MN, right? PR and PQ and MN are parallel. LRT, L to R to T is 28 degrees. No, LRT is an isosceles triangle and SLT is a straight line, right? So when I say isosceles triangle, right, that means this side is equal to this side from the visual here. And what do we know about
Angles are equal.
Right, these two angles will be equal now. Okay? So find the value of x, which is on this side here. So if we could find these two, what else we could find? If he has 20, and what here would be? Let me put that in red. If he has 28, what this angle here would be?
28.
28 also. 28 degrees. And we need to just find here, the one in blue. So how would we find, like we call this RLT. So RLT would be equal to 180 minus
28, whatever that is, you divide by 2.
proper. Very good, Mia. So this would be equal to what?
76.
76.
So it's just 152 and then you divide 152 by 2.
Right.
And get 76.
76, right? So here's 76. So here what going on here now, right? This part is 76. So the entire angle, which will be the blue angle and the red, form how much degrees? These two angles together.
108 degrees.
Right. So x is actually equal to 76 plus 28, which
Which would be 104.
104. Because vertically opposite angles are equal. Vertically opposite is like when you have an x, this angle on this side is equal to this angle here is equal to here. Right? Vertically opposite. Go ahead.
And if
So, we are on to part C here. They said the diagram either shows a shape T and its image Q after a transformation, right? So this transformation, what you all find looking like? Let me hear you.
like a reflection.
It looks like a reflection, but in what line? That line is actually the line we call
Y is equal to x.
proper. Y is equal to x. It's a line that comes from here and runs straight up here, and it goes through all the points where y is equal to x, right? That kind of, I didn't get to draw it properly. Just let me delete this and draw it back. I know I ain't getting it here now. I feel the page itself kind of off. The drawing itself kind of off, right? But it's basically a line that comes and goes through here, 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 here. Right? You all get the idea? Okay? I don't know why it keeps shifting. Right, there's a line in the middle there. The line is y is equal to x, right? It basically reflects each point on the other side. Okay? So, let's write that out. I still don't like how this line looking, you know. Right, so there we go. We're going to describe fully their transformation. So the single transformation, the single transformation, what you all put?
So if you don't put single, you lose a mark.
No.
Okay.
Is
I
a
put the transformation that maps T onto Q
proper.
is a reflection in the line. Y is equal to x.
Excellent. In the line, y is equal to x. On the diagram above, draw the image of T on after it undergoes a translation by the vector -1 and 6, right? So we go in. This -1 is movement to the left or right. That's what the top number is, right? The top number is movement to the left or right. The bottom number represents movement where?
Up or down.
Proper. Right? So -1 means we're going to the left. Positive 6 means we're going up. Point to note, you need to look at what we move in. We move in shape T. So we're going 1 to the left. I'm going to move 1 point and I'll build the whole image of that, right? So we're moving 1 to the left and how much up?
6 up.
6.
3, 4, 5, 6. So this point would be here. Now the thing about a translation, aka slide, is when you move it, is the original shape of the figure shifted or turned or anyway skewed? Any different?
No.
No.
It's the same.
It looks the same. So off this 1 point, I'm gonna build the whole thing, right? So I come in here, so boom, right? So 3 to the right, I go in 2 up. Then I go in 1 here. And then I come in diagonally. Everybody good there? What is it to label this?
M.
Done, you know. Done, you know. Keep it moving, Andrew. Keep it moving, Andrew. Let's go. So there we go. Right, so the triangle ABC, well, in ABC, AC is equal to 8 centimeters and BC is equal to 5 centimeters. Using a ruler compass only, construct triangle ABC, the line AB has been drawn for you. Now, CXC drew this line for us. So what I'm going to do is I will cut it here, right? And I'm going to put it on my app. Wait, boy, this thing really gotta be here, right? Right. Right. Cut it. And I'm going to put it over here. Right. Right. Boom. Right. So, let me see how this line measuring. I'm going to put it like 6 centimeters. Right. Let me put it like 6 centimeters. Right. Everybody see now? Draw it 6 centimeters in your book. This is what we're working with. 6 centimeters in your book, right? Draw it 6 centimeters. That's what we're working with. I'm not sure if we'll get the same thing that CXC got because I'm not sure what the length was. What the 100% length would be, right? Meaning that if this line was 100%, well, if this file was 100%, I will get the actual length, right? But let me work with 6, right? So we go in. What they said the next line would be? They said the next line would be...
AC was equal to 8.
Right, A to C is equal to 8. So let me draw... Here, let me show you all how we doing this, eh? If AC is 8, you open your compass to 8 centimeters. Right, do that for me on your ruler. Place your ruler, open it to 8 centimeters, and I'll show you all what we do. Put the sharp end here. Put the sharp end here. And with the sharp end there, we are going to make an arc above here. Right? Make an arc above there. Okay? Make sure it's 8 centimeters, eh? Then, what the next line is by? 5 centimeters, right? That is, so A to wherever C is, A to wherever C is 8. And then B to wherever C is would be 5. So I'm going to open my compass now to 5 centimeters. Right? Put us here on B. And I'm going to draw an arc so that the two arcs intersect. Right? So this is how simple it is to draw this line, you know? So you put your ruler here. And you're going to draw this line, right? Right, so we're drawing this line here from A to C. And then you're drawing the line from B to C. Everybody good there? That's how easy it is to construct this line. B to C. Now, once again, I'm not sure if this baseline was 6 centimeters, right? I
I think the baseline would have been more because the 5 cm coming down, it passing where the line is.
I mean, a pass so many liners, explain. So we're going to run it again because a student who has an actual past paper got 8 centimeters as the original line. 8 centimeters. And what the next line was? AC? AC is what?
Yeah, said I measured AC and I got 8.
What is AB? Is AB I want? So next we need to measure and state the value of BAC. So if they tell you to measure and state the value of BAC, you'll have to use your protractor, right? So for my diagram, I am getting like 40 degrees by exactly 40. What y'all get?
So I get 42.
Yeah, 40. So you see all of us getting 40. So we roll with 40. Right? 40 degrees, right? So angle BAC is equal to 40 degrees. Everybody getting any different? Right, let me hear what they do here. The diagram below shows an equilateral triangle. So all these bad boys are 13. All these bad boys are 13. Equilateral triangle means that all the sides are equal. Right? FGH, whose base is 13 centimeters and its height is h. What y'all did here? If this is an equilateral triangle, this line would cut this line at the bottom here in half. So what would be this? What this length on this side will be? You all seen that? Hello?
Yes, sir.
From here to here would be 6.5 centimeters, right? Because it comes like this is an equilateral triangle. Once these two sides are equal, this line here would cut this base line into 2 equal parts, right? So if here is 6.5, what we using to find h?
Pythagoras.
So b squared is equal to a squared minus c squared, where a is the hypotenuse, right? So b is what we're trying to find. B is h. H squared is equal to the hypotenuse squared minus the other side squared. And what you get in here? H will be equal to the square root of what?
126.75.
And the square root of 126.75 would be?
11.3 centimeters.
Talk down, no? Ooh. Ooh. What is it looking like? The diagram below shows 3 triangles, right? This is part C. 3 triangles P, Q, and R. Triangles Q and R are images of triangle P after it undergoes a double transformation, right? So, and you think clearly what that double transformation is? Let me hear before we even go down. From well, P is the original, right? So from P to R looking like our. From P to R.
Translation.
Right, and then I'm guessing it probably is a double transformation. So it probably went from P to R. A translation is like it slide to the right, and then it slide up, and then it looking like what? From R to Q looking like what?
A reflection.
A reflection. So let me see what they're asking for. Describe fully the transformation that maps P onto R. I didn't even need to see the question. I could have tell you that they were going to ask her first. So you see if you can figure out this translation vector now. Movement to the top number is movement to the what?
To the right or left.
Left or right. Okay, stick that on your head somewhere. And the bottom number will be movement where?
Up or down.
Talk to me. How much did it go to the what? And where did it go? Is it going to be on neck?
Went 2 to the right and 4 up.
2 to the right. So that means it's a positive. And then how much? 4 up.
4 up.
So I'm tracking the point at the top here. So we have our translation vector. So let me write that in now. So the single transformation is a translation relation of vector, not of vector, with two, 4. Right? So the next one would be movement from R onto Q. What R onto Q is, we need to find the image, the mirror line. Where the mirror line would be, by?
The line x is equal to 1.
Proper. Is this line here, right, guys? This is the line x is equal to 1, right? So you could check the distance from here to here, right? That's 2 centimeters. And then check the distance from here to here, 2 centimeters, right? So it's the same distance from this point to the mirror line, then from this point to the mirror line. So the single transformation, the single transformation is a reflection in the line
X is
equal to 1. Talk done or no? Question done. So the equation of this line would actually be the value of x where, well, that x passes through here, because it's a vertical line, right? And it's passing through where x is 1, because and this is 1, you have 0 here, then you have 1 here, then you have 2 here, then you have 3, then you have 4 going up the road, right? So this is a vertical line passing through where x is equal to 1, right? Amelia, you good there? So we on to June 2023, 3-part A. The diagram below shows a semicircle with diameter AC, right? So this is your diameter here. B is a point on the circumference, and AB is equal to BC, which is equal to 8.2. So this bad boy over here is 8.2 centimeters, right? So state the geometrical name for the line AB. What AB is?
chord.
Right? A chord is a line that goes from one end of the circumference to another and does not pass through the center of the circle, right? That will be a diameter, even though a diameter is a chord, eh? So find the value of the radius of the circle. So the radius of the circle will be where? From here to here? This is your radius here?
You know our angle in our semicircle is 90 degrees, so you could use Pythagoras theorem to find the diameter and divide that by 2.
Good. In God mode, by dog, by. There we go. So angle in a semicircle is 90 degrees, right? So angle in a semicircle is 90 degrees, right? Now this is not circle term, so all you could probably do is just state that ABC, or you could put when ABC is equal to 90 degrees, we could proceed to say that AC squared, which will be the hypotenuse squared, is equal to 8.2 squared plus 8.2 squared. So AC would be equal to the square root of what?
134.48.
134.48. AC would be equal to
11.6.
11.6 centimeters. Can somebody second that? Can someone second that, please? Quad. Oh, this is the end here now. So there we go. This end done. We need to find the radius. So therefore, the radius would be equal to 11.6, because that AC is the diameter. AC is the diameter. So it will be 11.6 divided by 2, which will be equal to what?
5.8.
Right, talk done. Huh?
360 over n.
360 over what?
over n.
No. Sum of interior, because they give us, they say each interior angle in a regular polygon is this, right? So sum of interior angles.
So will it be 9 minus n minus 2 multiplied by 180?
Right. This is the main formula we're using, right? So if I want the sum of the interior angles, that could actually be regarded as 160n. When you take 160 and multiply it by n, n will be the number of angles, well, it's the number of sides in the polygon, which will ultimately mean the number of angles in the polygon. So 160 multiplied by n would actually be equal to n minus 2 multiplied by 180, right? Okay? You can equate these two. 160 multiplied by n. So if you have how much ever angles in each angle, when you multiply that by the number of sides, you will know the sum of the interior angles. So let's form a little equation here now. So you multiply 180 by 2, you multiply 180 by n. So 160n is equal to 180n minus 360, which will give me what? What we doing here? What we could do here? All you want to carry this here? 160n minus 180n is equal to negative 360. 160n minus 180n will be how much n?
20n.
Negative 20n is equal to negative 360. What do you do with the negative 20 when you carry it there?
Divided.
Negative 360 divided by negative 20. Therefore, n is equal to
80.
80. That's how much sides up.
18.
Oh, I want to know. I don't know where I get 18 from. I don't want to know. 18. So,
I do 180 minus 160 and I get 20 and I equal.
right. So for part C here, they said draw the diagram below shows a trapezium A. Draw on a square grid. Well, drawn on a square grid, right? On the diagram above, draw the image of A after it undergoes a reflection in a line y is, well, x is equal to -1 and label it A prime. All right. So where would x is equal to -1 be? Hello. So this line here will be the line x is equal to -1, right? Now, they want you to draw the reflection, right? After it undergoes, after it undergoes a reflection in the line, x is equal to -1, right? So where we going? We're going on this side, right? So I'm just going to reflect 1 point, right? And then we're going to draw the entire image of that 1 point. So we're here now, right? So I went 2 to the line, and then I went 2 away from the line, right? So we go in. Now the thing is, you're going 2 centimeters this way, right? Then you're going 2 centimeters up. Then you're going 1 centimeter this way and diagonally down. Right? That's the only one I get the autocorrect for. Right? So this here will be the image. And what is it to label the image?
A prime.
A prime. Right? Translation vector 4, -7. Alright, so if the translation vector is 4, -7, and they say the label is A double prime, so I'm going to write it here 4, -7, right? What the top number is? Movement where?
To the left or right.
And the bottom number is movement where?
Vertically.
Up or down, right? AKA vertically, right? So where we going? 4 to the what? 4 to the?
4 to the right.
Because it is
Positive.
positive, right? So we're going 4 to the right. So we could do same 1 point. So it'll actually be right here. 4 to the right is 1, 2, 3, 4. So you're right here. And then we're going 7 down, right? Because it's negative 7, so you're going 7 down, right? So we're going 7 down now. So you're going 1, 2, 3, 4, 5, 6, 7. Now this point here is going to be here. So I want to ask a question about a translation. Is a translation going to change how my object looks in any way?
No.
No. So you know you're going to draw that same thing up there, right, guys? So we come in here, boom, 2. You're going 2 this way. Then you're going what? You're going 2 up.
2 up. And 1 across.
1 across, and then diagonally down. Diagonal. I ain't get the autocorrect now. Alright, so then they come in diagonally down here.
Label it A double prime.
A double prime. Right? That's it there? Question done or no? Right. So I want you to pay particular attention to this question. I just catching our vibes that some kind of rotation coming. And if it's not a 180-degree rotation, which will be very easy, it would be a 90-degree rotation, which will be very stressful, right? So the following diagram shows 3 quadrilaterals P, Q, and R on a square grid. Q and R are the images of P after it underwent 2 different transformations, right? So P is the original, right? So there we go. On the grid, draw the image of P after a translation by vector 10, negative 4. 10 will be movement where it's a translation, aka slide. So 10 is movement where left or right. And negative 4 will be movement where?
Down.
Up or down, right? So it's down in this case, right? So 10, because it's positive, we move into the right. So let's start to move P, yes? We move in 10 to the right. How far away? 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10. And how much down? I want to go down one time. 1, 2, 3, 4. Right? So, question, my children. Let's confirm that 10, 4. Right. If it's a translation, is P going to look any different than how it is looking right now? No. So, let me build it right here one time, right? So, we're going boom. Right? Then bang. Bang. Alright, I ain't get the autocorrect, but we run it, so bang. Alright. So, what are we labeling this?
P prime.
P prime. Look at right there. P prime. Label this image P prime. P prime. What's next? A reflection in the line y is equal to 0. Label this image P double prime. The line y is equal to 0 would be, watch, is a line that passes through where y is 0. So the line that passes through where y is 0 is actually our what axis? Y'all seen it there? Yeah, is the x-axis. The x-axis is a line that passes through where y is equal to 0. Right? It's the x-axis. This is the line y is equal to 0. Right? So let's reflect this bad boy. So we go in boom, 1, 2, 3, 4. So we go in 4 to this, right? So how much down we going now? If we go 4 to the mirror line, how much we going down now?
You going on my 4?
Let's go. 1, 2, 3, 4. So the bottom point is going to be here. How is this image going to look? Is it going to look the same way?
It's going to look flipped.
Flipped. Because a reflection is a flip. Alright? So let me flip that bad boy. So this will be, so we join this upside down. So you're going so boom. Right? Then you're going so bang. Bang. And then bang. Everybody good there? This will be labeled P double prime, right? Now here what I'm gonna do, I wanna move some of these, way, boy, I should have, all right, I know how to do. Okay, I'm moving some of these things here, right? And what I'll need to do, because what should the next part asks? They say describe fully the transformation that maps P onto Q. So P onto Q, that's so. I want to cut this and make two images of it because it's two different things I have to do. And I want to show you all it clearly, right? So we go in here now. All right, copy. All right, let's make some space there. Boom. Move that bad boy. All right. So obviously, this is what? Obviously, they want us to describe fully the single transformation from P to Q. From P to Q is our
Enlargement.
right. It's an enlargement. But what do we need to find? We need to find two things. What's the first thing? Center of enlargement and the
Scale factor.
let's go. So here what I'm gonna do. Center of enlargement, I need to connect corresponding coordinates, right? Well, the corresponding points is what we need to connect them and extend it, right? What's going on here, buddy? All right, I'm gonna use this. That'll be easy. And remember, this do have auto correct this up. So right, we're going here now. Boom. I'll put him right there. Bang. Then you come in here now. Let me do this sooner. This and this. Bang. All right. And if you want to do our next one, wait. All right.
So again, negative 10,7.
That's what it is. Bang. Then you come in here. Bang. Right? So my center of rotation will be this bad boy right here. Right? This will be negative 10 on the x, comma, this is 6, this is 8, so in the middle here will be 7. 7 on the y. Right? So we have a center of enlargement. But what is my scale factor? What will be my scale factor? So here are we focusing on? Let's focus on the diagonals. Alright? So this diagonal coming on here will be what? How much?
3.
3. And this diagonal coming on here will be what?
9.
9. Alright? So 3 and 9 means that my
Scale factor.
my scale factors is going to be 9 divided by 3, which is 3. You can focus on this line here too. Now we can now see this run from here to here and it's diagonal. Right? So if here's 1 and here's 3, 3 divided by 1 will give us the same 3, right? So this is my scale factor. So I have my scale factor, I have my center of rotation. Not rotation, enlargement, sorry. Alright, so there we go. Sleepiness talking here. So there we go. Let me write out this bad boy. The transformation, the single transformation is an enlargement is an enlargement with scale factor, or let's put off. I keep using that word with off of scale factor 3, right? And center -10, comma what? What was -10, comma?
Comma 7.
7, right? 3 marks at that. Now we go into the quadrilateral R. Right, so here I want to do a separate one for this, right? So let us add a page here. Okay, boom. Right. So P onto R is obviously a what? P onto R is a what?
Rotation.
Right? Because it can't be an enlargement, it cannot be a reflection, it cannot be a translation. Okay, it cannot be any of those. So what is it? It is a rotation. So stay with me. I want all you to do this. You're going to draw 2 lines. One. So you're joining 2 corresponding points, right? Well, 2 pairs of corresponding points. Now this point here would I'm joining the 2 at the bottom and the 2 at the top. So you're sure, you know, right? This is the bottom, this is the top, right? And then we have to bisect these lines. So we're going to bisect these lines now, eh? So in order to bisect these lines, this is the halfway of the line will be like around here. You go a little more than half. You're gonna draw an arc. I'm gonna draw it in red. I'm gonna draw an arc here, boom. Then you're gonna bring your compass on this side and draw another arc so that the 2 arcs intersect. Right? Draw another arc here. Boom. Right? Then you have to do the same thing on the next line, right? So let's draw the arcs and then we will draw the perpendicular bisectors, right? So you're gonna come here. Let me do this in a different color. Let me do this in green. So this will be 1 arc here, so boom. Right, then it coming on this, you're putting a sharp point here now. And I draw another arc so that the 2 arcs intersect. Boom. Right, those are my 2 arcs. So I'm going to draw this perpendicular bisector in green, right? So I'm going to come from here and I'm coming up here. Right, you're trying to find the center of rotation. How far to extend this, but I know it looking like it right there. Right, so all right, that's 1. And then let me draw the red one now. So we come in here now. I just starting from where the 2 arcs intersect here, making sure they line up. Boom. Well, you see where the center of rotation is?
-4, 2.
Right, let me write that in blue, eh? This will be my center of rotation, right? And that will be -4 on the x and +2 on the y, right? So we have the center of rotation. Now we need to know how much degrees this rotation was, right?
That's going to be 90.
It would be 90, right? Now, how do we know it's 90? Let me show you all here. Alright, so what color to draw this in? Let me go in orange. So you're drawing a line from here to the center. Boom. And then from the center to the same corresponding line. You see now it is exactly 90 degrees. Right? So if you take a protractor now and you measure this, you will get 90-degree rotation, right? And what direction we moving in? Now you can do behind here, but if you do behind here, what your arm rotation will be? 270. If you go clockwise, you don't know it is 270. So this is 270 degrees. Clockwise, or wait, what going on there, boy? Clockwise, or you can put 90 degrees anti-clockwise. Right? Anyone you want to do. Okay, so I hope you all were following there. So the single transformation is our what? The single transformation is a rotation of
90 degrees.
in an anti-clockwise direction about what?
About -4,
About center -4, dose. Alright? So what it's saying here, the diagram below shows 4 shapes P, Q, R, and S on the square grid, right? So you have 4 shapes here. P is the original, and I like how they put P shaded, so you know that's the original, right? So we are going to describe fully the transformation that maps P onto shape Q, right? Hit me now, what maps P onto Q? What it is?
Rotation.
A rotation, but it's a rotation of how much degrees?
180
So
degrees.
that is the easiest rotation to work with. So let me connect some corresponding points now. So let me go from here to here. Or I do that? Because we're trying to find the center of rotation. And then from here to let me go from this one to down here. Or you see I'm the center of rotation. Yeah, look at done. We done seen it here, man. And because it's a 180-degree rotation, it could go left, it could go right, doesn't matter, right? So let me go. So the single transformation is a rotation of 180 degrees in a clockwise. I would just put clockwise. Rishi, talk to me.
Yes, sir. I have to leave now, right? I have a class right now.
All right, no problem, bro.
All right, sir. Take care.
Yeah, you too, bro. In a clockwise direction. In a clockwise direction. About what? About center?
About center 7,7.
Right? Let's work. R. So P, remember P is the object, eh? So P onto R is our
A reflection in the line by x is equal to 1.
X is equal to 1. So here how we're mapping this, guys. You can check the distance from here to here, right? And you will see that it is 4 centimeters apart. So half of 4 is 2. So you know that your reflection line would be in the middle here. Right? Boom. So it passes through where x is equal to 1. So that's my reflection line or my mirror line. Right? So let's write that in. That one is a little easier here. So the single transformation, you see they give you more marks to the for the rotation, is a reflection in the line. What was?
X is equal to 1.
Proper barak. Right? So where we going next? We're gonna find P onto S. P onto S is clearly a what? P onto S is clearly a enlargement. So what we need to find? Two things. Center of enlargement and our scale factor. Scale factor is dog food, but let me see if we can locate the center of enlargement now. Alright, so we come in here, so alright, I ain't get the autocorrect there. Alright. So we coming through these two bad boys here and let me extend them right up. Right? Boom. Let me do this one right here. Bang. So my center supposed it looking like it right here. I just probably draw that next line a little off.
Yes, I guess 7-11.
7-Eleven by, you know 7-Eleven, Andrew?
A grocery, I think.
Yeah, is a gas station. This one will just be lining up with this one here. So you don't get enough. You don't have to do all. If you do two, you'll get the center of rotation of enlargement, sorry, one time, right? So this will be 7-11. Center of enlargement, right? So there we go. What's the scale factor, by the way?
2.
Scale factor would be if we map this line underneath here, this line underneath here is 4 from here to here, and from here to here is how much? 8.
Yeah.
So the scale factor will be 8 divided by 4, which will be 2. Right? So we have our scale factor, we have our center of enlargement. So the single transformation is an enlargement of scale factor. This writing part glitching me. Of scale factor. How much scale factor is 2, right? 2 with center what?
With center 7,11.
Right, yeah, 7-11. 7-11, right? On the grid above, draw the image of the shape P after translation by vector -2 and 3. -2 would be movement where?
To the left and up.
Right, left. I put in left or right, so that, you know, you will know that negative is left, you know that positive is right. And this will be up or
Down.
Hey, the killer one, you have a question? Hand was up. So up or down, right? Left or right. So let me go. So -2 means we going to the left. +3 means we going up. So same P, eh? So 2 to the left. 1, 2. And how much up? 3 up?
Yeah.
1, 2, 3. So we build a new whole image of this point here. So you're going 4 to the right here. So that'll be this line underneath here. That's 4. Then you go 2 up. 1, 2. I ain't get the autocorrect there. Then I go 1. Then I go 1. Then I go 2. Then I go diagonal. What is it to label this?
Label it T.
T. Right? Proper thing. So, January 2022. The box below contains the name of 5 quadrilaterals. Choose the name of one quadrilateral from the box that best completes each statement. So if something has no lines of symmetry and has a rotational symmetry of order 1. Which one you have no lines of symmetry? Which one?
Attribution.
Chop. Woo. So this will be a trapeze right? Something has exactly 2 lines of symmetry and 4 right angles.
Rectangle.
A rectangle.
Rectangle proper. Oh, let's come alive with this one, boy. If something has 1 line of symmetry but no rotational symmetry.
Okay.
Right.
Okay.
Talk done or no? So, hey, that's right. Don't what we're trying to find here. Well, I guess in read that. So for this question here, part B, they said to determine the values of Q and R, right? Now, Q would simply be equal to, before I even go to R, here will be corresponding, right? Here will be 54 also. These two angles are corresponding. And then if here's 54, then Q would be equal to 180 minus 54, which will give me what?
126.
126 degrees, right? So, Barack, watch how here's 126 and here's 71. So you see how it doesn't apply to quadrilaterals that are not in a circle. Cyclic quadrilaterals only apply to a circle, right? So we go into R now. R is simply equal to 54. Now they did not ask the reasons here, but this reason would have been vertically opposite angles are equal. Once you have a X, right? This angle is equal to this angle here. And this angle here is equal to this angle here. Vertically opposite angles are equal. And then they said give a geometrical reason why P will be equal to 71. What is the geometrical reason why P is dog food? Alternate angles are equal. Alternate angles are equal. Proper. Right? For those who not seen it, it's like you're looking for a Z, Z. So this angle on this side is equal to this angle on inside. It must be the angles that are within the, on opposite sides within the parallel lines, right? Okay, parallel line laws were used here, right? So this is what we asking here for this one. So this is January 2022 part C. They said the diagram below shows triangles X prime, Y prime, Z prime, and X double prime, Y double prime, Z double prime drawn on a square grid. Right? Now you have your two triangles here. The triangle X prime, Z, Y prime, Z prime is the image of triangle X, Y, Z after an enlargement of scale factor 2 with center 5, 1. So that is the image after the object was enlarged, right? So if your center of enlargement is 5 on the X, right, and 1 on the Y, which is here, right? This is the enlarged image. So what's something? If I connect the vertices of this triangle to here, right? I ain't like how that come out. That's all. Let's see if I can get the trying to get the autocorrect. Right. I know good. Boom, that's one. Then bang. Wait, boy, this autocorrect ain't coming in here, but I don't know what going on here. That's all in the evening, huh? Alright. Yeah. So what I did is I connected, well, I drew a line from the vertices of the enlarged image to the center of rotation, which is 5, 1, right? So I think I'm off by a little thing with one of them, right? But here this is going to go, right? So if I want, it's like I'm trying to draw a triangle. What is the length of this line here, which is X prime, Z prime? What's the length of this line here? And it'll be 4, right? 4 units or 4 centimeters because it'll be a 1 centimeter grid graph here. So watch it. This is 4. So the line, if the scale factor is 2, what will be your original line? Let me see if you can figure out that. What your original line will be? Huh? 2, right? So I'm looking for a distance from this line to this line that is 2 centimeters. And you will clearly see it here. You all seen that? So this is where X is, and this is where Y is, right? And then you want to go across here is 2 centimeters up here. So you know the distance from X to where Y is will be 1 centimeter. This is Y. So you will see that your original triangle is right here. This is your original X. Wait. X, Y, Z. The Z underneath here. Why really do that, boy? Hold on. This will be Z underneath here. Z. Right? So that is XYZ. That's my original triangle. So they say to draw XYZ, the object of the triangle, X prime, Z prime, Y prime, Z prime. And we did that, right? Then they said triangle X prime, Y prime, Z prime is mapped onto triangle X double prime, Y double prime, Z double prime by reflection in the line P. State the equation of the mirror line of P. What would be the equation of the mirror line?
X is equal to 2.
X is equal to 2. So what you could do, check the distance from here to here, check two corresponding points. You would get 6, right? So halfway in between 6 would be right here. Right here. So you have 3 and 3 on either side. Your mirror line will be in between here. Boom. So it'll be X is equal to 2 would be the equation of the mirror line. 1 mark. That's all they wanted to do. Let's state X is equal to 2. Right, so we go in. The diagram below shows the triangle PQR in which triangle QPR is equal to 62 and PQR is equal to 90 and PR is equal to 11. So PR will be my what?
Hypotenuse.
So we want the size of angle PRQ. How we finding that?
180 minus 62 plus 90. You get 28.
28 top down there, right? 28 degrees, and then they want the side RQ. So what we using? Opposite and what?
Opposite and hypotenuse.
Right, so that'll be sine.
Sine 62 is equal to RQ over 11.
Right, so opposite over hypotenuse. So RQ would be your opposite, 62 is your angle, 11 is your hypotenuse, right? So this would be sine of the angle 62 is equal to opposite, which is RQ,
Over 11.
over 11. Carry 11 here, what are we doing with it?
Multiply it. You get 9.71.
So RQ will be equal to, somebody second 9.71.
Yes, sir.
Centimeters.
Yeah.
Centimeters. Right, proper. So we're going down now. This part is dog food, right? So they gave you this here, right? The diagram shows 3 triangles X, Y, and Z on the square grid. Triangle X is mapped onto triangle Y by reflection. State the equation of the mirror line. What's the equation of the mirror line which sends X to Y? Let me hear you.
Y is equal to 0.
Y is equal to 0. Proper thing. That's this bad boy here. Is this line here. Right? This line here. Y is equal to 0 is the x-axis, right? So if they ask you for the equation of that line, you can't put x-axis, eh? You have to put y is equal to 0. That's the equation of the mirror line. Describe fully the transformation that maps x onto z. X onto z. So I want you all to, it's a rotation. I want you all to go through the process. Connect the at least 2 corresponding lines, bisect the lines, see where they intersect, give me my center of rotation, and also tell me how much degrees it's going to be rotated by. I'm giving only a full 2 minutes or 3 minutes for that. So I see Andrew did out the other 2 parts, but this is what we need to focus on. It said describe fully the transformation which maps x onto z. X onto z will be this onto this. You can clearly see it's a rotation, right? But we need to show the center of rotation. We need to show how much degrees it's being rotated by, right? So let me put this on my app, right? So we're gonna snip this and we carry it across. Boom.
Also, I had to bisect it and show is 90.
Correct, right? So that's what I'm gonna do now. So hold straight. Right, boom. Right, so we go in. So in order to show that what the center of rotation is, I need to first connect 2 corresponding points, right? So I'm going to connect, we know this point here is definitely this point here. Boom. Right? Then, which point? We could do this point and we could do this point on top here. The point on top there is the point on top here. But I look for 2 distinct points. We now have to bisect each one of these lines, right? So I come in here, sharpen here, boom. I want to zoom in now. Hold on. Right, watch it, eh? Sharpen here. Whoa. Sharpen there, bow. Then you need to open your compass a little more than halfway. Right? And then you're going to draw an arc here. Bang. Like one arc. I hope you all seen it there. One arc. Right? Then with the same measure, you're going to put your sharpen here. And you're going to draw another arc so that the two arcs intersect. Boom. Then you're going to draw a line to bisect these two lines. Ooh, la la. And extend it, right? So I'll just extend it till probably here. Right? Then I'm going to repeat the same thing with this one up here, right? Right, so we're going to bisect this line now. So you put your sharp end here. Sharp end here. You open your compass a little more than where you know the halfway point would be, right? So let me do this in a different color. I'm doing this in red. Might have to come down a little bit here, boy. Right. Alright. So you come in here, so bow. And we're going to draw an arc above and below. And then you're coming on this side now. Put your sharp point here. And you're going to draw another arc so that those two arcs intersect. Alright? Then you're going to draw a line straight through these 2 points here. What is my center of rotation? Where was the two lines intersecting there? Wait. Where are the two lines intersecting there, guys? What are the coordinates of this point?
1 and 1.
Huh?
Negative 1 and 1.
Negative 1 and 1 would be where the blue line. So you're looking at where the blue line and the red line intersect.
Negative 0.
Negative. Hey, watch that. This thing at negative 0. That's wrong. There's no such thing as a negative 0.
I see.
Yeah, and that was on CXC paper. Eh? Watch. This is CXC's paper. Watch. Where it is. Watch. This is our full CXC paper, right? Negative 0. Craziness. Right? So there we go. So what will be the coordinates of this center of rotation here? Anybody? So 0, comma 0. Right? So 0, comma 0 is your origin. And how much degrees is this moving? So I can actually draw a line. Right? So you're drawing a line from, I'm going to do it in a different color. Green. So you have to draw a line from here to the center of rotation, and then from the center of rotation to the corresponding point that I just came from. How much degrees that is? It clear as day.
90 degrees.
90 degrees. And in what direction we going?
Anti-clockwise.
Anti-clockwise. So let me write that out. Right? I want to snip this and put it back on the next side though. Hold on. Boom.
Or
Bam.
270 clockwise.
270 clockwise. Very good. Or 90 degrees. I'll go to 90 degrees, bro. Right. Anything to do less writing. Why does it still open? Well, look at this. Right. Alright. So we come in here. Let me put right on the side here. Boom. Bang. Bang. Okay, let's put this here now. Now let me put it here. Because I'll go and do the other parts on this new one here, right? Right, so we good there. Let me start it right. So we have the center of rotation. We know the direction. We know how much degrees, right? So let me work. So the transformation The transformation is a rotation of 90 degrees about the origin, right? The origin would be 0, 0 in a or an anti-clockwise direction, right? Now, we go in here next. On the diagram on page 10, translate triangle Y using the vector -7 and 1. -7 is movement where?
Left or right?
And the bottom one will be movement where?
Up or down?
Up or down?
Right? So we go in 7 to the left and we go in 1 down. Label this one V. There we go. Right? So which one we moving?
Says one up, not down.
1 up, sorry. 7 to the left, 1 up. Yeah, correct. We move in triangle Y. So let go. 7, 1, 2, 3, 4. Wait. 4, 5, 6, 7. All right, so yeah. Are we just going 1 up? So this point would be here, but watch this here. I had a bill, so it's supposed to look the same way as Y, right? So you're coming this way. How much you coming this way, boy? 5 or 6?
6.
6. So that 1, 2, 3, 4, 5, 6, right? Then diagonally here, you're coming down here, 2 down, and then you're coming diagonal to this, right? So you're coming boom. I do this right? No. This is supposed to be here. Yeah, this is supposed to be here. Yeah, correct. Correct. Move that. Bring this here. Alright. So that's what we labeling this.
V.
V. V. Alright. And then the last one now, they said on the diagram, the diagram above, enlarge triangle X about the center C, which is 0, 0. The scale factors are half, right? So it come like you're shrinking it, right? Label that W. So let me draw a line from the center to triangle, each vertice on triangle X, right? So I go in, let me do some different color. So you're going from here to here, right? Then you're going from here to up here. Boom. Then you're going from here to here. Right? Now, this triangle that we are going to draw here to here. Right. I got the autocorrect there. No. Let's see if I can erase this. Right. So, half of this angle here, of this line here at the base, would be 3. So we're looking for a distance from this line to this line. That would be 3. That's actually this distance from here to here. Everybody good there? That's this distance, 3. Then you're looking for 1. This is 2 centimeters up, so it'll be 1 centimeter up. So that will be here. So you're kind of touching this triangle here. Boom, bang. Boom, bang. Everybody good there? And we label this what? What are we labeling this? W. Top down, no? The diagram below, not drawn to scale, shows pentagon V, W, X, Y, and Z. In the pentagon YZ, which is this here, this is YZ, is parallel to XW. This one across here. These two lines are parallel. Then they said YX, which is this bad boy here, is parallel to VW, this bad boy above here. Angle XYZ is 114, and angle VZY is 98, right? Okay, that's these two angles here, right? Now, determine the value of WXY, W to X to Y. So that will be this angle here. Now, I need to hear it from you all. Now is not time to say quarter. Speak up if you really don't see something. Tell me. Let's get it done, right? How do we find this angle here? Let me hear you all.
You do 180 minus 140.
180 minus 114. And why will this be so? Because what?
Because they are co-interior.
Co-interior. So for those who not seen it, if you have a pair of parallel lines, right? And then you have a line going from one parallel line to the next, which is what going on there, right? This angle here, which is the 114, and this angle here, which is the angle we're trying to find, A and B, will add up to be 180 degrees because they are co-interior. So this will simply be equal to 180 minus 114, which will give us how much? 66. 66 degrees. Come on, talk to me. Now it's not time to. Right. So the diagram below, we here now. Angle ZVW. Let's read, I got to read over the question, yes. ZVW. ZVW. ZVW is this bad boy here. Right. So one of the formulas you need to know before we even activate that, right, is you need to know the sum of all interior angles would be equal to n minus 2 multiplied by 180, right? But before we jump to that formula, what do y'all think we should do? Let me hear y'all speak again. You have a pair of parallel lines. 1, 2. A pair of parallel lines, right? Then you have your transversal here. Boom. Right? I'll put a little slant because it's a little slant. This angle here, which is what we just found to be 66. These are a pair of parallel lines, right? And then this angle up here, which we need to find this angle up here before we could find the angle that they are asking us for, right? So this angle here will be 66, and then this angle here is the unknown that we're trying to find, right? 66, and the angle above there will be co-interior, right? And co-interior angles add up to 180. So I'm going to find VWX first. VWX would be equal to 180 minus 66. How much that'll be?
140.
114 degrees, right? So up here is 114 also, right? So now we can proceed to find this here because that angle will be equal to the sum. I'm going to put n minus 2 in brackets multiplied by 180. This gives us the sum of all the interior angles minus all the other angles, right? Which should be 114 plus 98 plus 114 plus 66, right? As a matter of fact, I'm going to put in n one time. N would represent the number of sides in the shape. How many sides do we have in that shape there? 5. That's what we talk about. Oh, I need more people understand, man. 5, right? So you know you can actually build this out on your calculator. Shana Shepherd. Shana.
148 degrees.
Hold on, eh?
Yes, I get 148.
100 and how much?
48.
148 degrees. Oh, let's show that all again. Let's work it out.
Yes, you're correct. 148.
148 is your final answer. So that is how much degrees ZVW is. Right here is 148 degrees, right? Proper thing, right? We go down here now. So they gave us a point. They gave us a letter there, the letter A. And they wanted to enlarge it by scale factor 2. Then they wanted to translate it. So come on, let's get this done. So let me go. The letter A and a point C, which is 66, are shown in the grid below, right? So they want us to enlarge A by scale factor 2. So if I enlarge an A by scale factor 2, right? Now the center of enlargement, right? So the center is 6. So let me draw some lines, right? So it's like I'm coming from here. Give me the autocorrect now. That's I'm gonna get the autocorrect. Now, with respect to multiplying a scale factor by each coordinate, you can only do that if your center of enlargement is 0, right? You cannot do that if your center of enlargement is not on pause. Right. So the distance between this point here and this point here would be 2 centimeters. So how wide would that space be in the enlarged image? Let me hear you. 4. Why would it be 4, guys? Why would it be 4? Scale factors 2. So 2 multiplied by 2 will give me 4. So I can figure out where I have 2 points 4 centimeters apart. Now I guess this is supposed to be here. So that means my line a little off, right? So it's here, right? This is what you all got? Raise your hand if you got this, please. Right. Proper. So that is 4 centimeters apart. And then I can check the distance from the bottom here to the top here. That is 2. So the enlarged image, it would be 4. So I check the distance from here, center here going up. So that means the top of the A would be here. So let's draw it here. I'm going to draw it in red. All right. So we go in, boom. Wait, why that's doing that? Okay, let's go here. I don't know why it become an arrow, but that's one side. That is 2. Right? And watch, our slash is 1 centimeter down, well, a little above 1 centimeter down. It's kind of in between the 2 smaller boxes here. So this one will be 2 centimeters down, and we'll put it a little higher. I ain't getting the autocorrect at all today, boys. This autocorrect sometime-ish. Right? So this will be here. This is my enlarged image, right? Everybody good? Everybody good there? Now, we are going to translate the letter A by using this vector, right? So hit me. The top number represents what? Let me hear you. Movement where?
Movement to the left or right?
Left or to the right. And the bottom number represents movement where?
Movement to the up or down.
Up or down, right? So, because it's negative, we move into the... And then because the bottom number is positive, we move in...
Up.
So 3 to the left and 2 up. So we go in 1, 2, 3, and then you're going 2 up, right? 1, 2. So our new head, well, the top of the A will be here. Now this is not an enlarged image. So our translation, it looks the same, right? So we come in diagonally down here. Boom. Then we come in diagonally down here, bang. And then we coming across here, bang. Right? Talk done. So what you could do, I will just erase this. So this is my translated A. Right? We good there, my children? So we're doing this one in real time because if we finish a little early, that's a small thing, right? That's a small thing if we finish a little early. So let's go in real time. Hit me. This is a hexagonal prism, right? So we're looking for how many faces does this prism have in real time. Hit me.
8.
8. So around you'll have 1, 2, 3, 4, 5, 6 moving around. And then you have the 2 faces on either side. So it would be 8 faces. And then edges, right? Remember, these are the edges. Like this is an edge. Okay? This is an edge. How many edges do we have?
I think you'll have 18 edges.
Right. So how much edges going around? You have 6 going around. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So 6 trees are 18, yeah. 18 edges, and the vertices will be these 1, 2, 3, 4, 5, 6. And then you have 6 on the next side. 6 and 6 is?
12.
Proper. Real time. Real time. Right? So this bad boy here, you all have to get your compass. Right? And I want you all to try this. Let me do it. So let me assess it together, right? They said a sports club owns a field PQRS, right? In the shape of a quadrilateral. It is a quadrilateral. So a scale diagram of this field is shown below. So this is a scale diagram, right? So they say that 1 centimeter represents 10 meters, right? 1 centimeter is 10 meters. So if I take a ruler and measure 1 centimeter here, that'll be 10 centimeters in 10 meters in real life, right? So we're going now. In the following part, show all your construction lines, right? The field is to be divided with a fence from P to RS. So it's coming from P to RS. So this coming down here, somewhere down there, right? From P going down to RS. Let me see what else they saying. So that different sports can be played at the same time. Each point on the fence is the same distance from PQ as PS. Each point on the fence is the same distance from PQ. So PQ is whereby from PQ as PS. So wherever I drop this line, it must be the same distance from here to here and from here to here. Using a straight edge and a compass only, construct the line representing the fence, right? So this is the only way I can see. Anytime they're talking about like straight same distance from PQ to PS, this is what we'll do, right? I need to carry this on my app. So let me cut this. Boom. Bang. Copy. We go in here. Okay. Discard. Oh. Alright, there you go. Paste. So this is it here, right? This is how we're going to do it. Boom. I'm going to put my sharpen here because it's from P, right? So if you want the same distance between the two, what I can do is I can make an arc here, right? I want it in blue. I can make an arc here and another arc here, right? So what this will do, it will give me, once I come here, right? I put the sharp end where these two arcs meet, and I put another arc around center mass there, boom. And then you put this arc, this sharp end here, sorry, and then you make another arc here. So what this does, it gives me the midway point between the two lines, right? And then I'm going to draw a line from P straight down to RS, right? So let's put a line there now. So we're going to put a line here coming from P and you're going to RS. So this represents is the same distance from here. So look at it. The same distance is like if I draw a line straight across here, a straight line, it'll be the same distance from here to here as here to here because of how I drew these arcs, right? Raise your hand if you are clear. Raise your hand if you are clear. I want to make sure they're clear, right? So you don't understand the kind of heights that they use there, right? I don't know why I'm getting this to move now. Hold on. Right. So we good. Let me see what else they are asking here. They said write down the length of this fence in meters. Right? So we want the length of the fence that we just drew in meters. So we go back here. Now, I don't know if this is 100%. So this answer might be a little different to somebody who has the printout. Because this might be 100% line, right? Well, 100% drawing because they said it's a scale drawing. So I am basically getting 9.7. So that's why I'm going with, right? So mine is working out to be 9.7. So that's what I'm putting here. So this will be 9.7 centimeters, which will be equal to, if I'm going from centimeters to meters, right? What would I do? It's like I'm going from left to right. What do I do, guys?
Multiply.
Everybody good there? So it's like 1 centimeter is equal to 10 meters, right? So I'm going from centimeters to meters. I'm going from I'm left to right, so I have to multiply. So I'm multiplying this by 10. So this will be 9.7 multiplied by 10, which will be 97 meters is the length of the effect. That's like the length in real life. Let's see what else they are asking us here. Okay, we have a transformation next. Anybody needs to write anything in real time? Because I realized to draw the graph something might take us a little too long, even though I think you all should do that. So the quadrilateral PQRS and its image P prime, Q prime, R prime, S prime are shown on the grid below. Write down the mathematical name of the quadrilateral PQRS. Hit me.
Trapezium.
Trapezium, right? That is dog food. They said PQRS is mapped onto its image P prime, Q prime, R prime, S prime by an enlargement of scale factor K about a center C. Using the diagram above, determine the values of A, B, and K. So what do? We need to line up the corresponding coordinates, right? So we go in here. Let's start with Q. So I put in Q and I extending it, right? Burn. I feel I was a little off there, but we go see what's going on. So we do our next one. Please. I just think so wicked, boy. Alright, let me do this one right here. You can come right here now. Alright. Bang, look at right there.
-4,1.
Yeah, that's itself. It's right here. I had a little off, but it's right here they intersect, right? It'll be -4 and then 1 is here, right? So you just need to do 2, you know, and you'll be able to see what the enlargement is, right? So it'll be well, the center of enlargement will be -4, comma, +1. Then scale factor. If this baseline here is how much that is? 6, and this baseline here is 2. What will be my scale factor, my children? Proper. 3, right? So they wanted A, B. So A center A comma B would be equal to -4 comma 1, and your scale factor would be equal to 6 divided by 2, which is 3. How it looking? How is it looking? Using a ruler, a pencil, and a pair of compasses only, construct the triangle NMLM, in which LM is equal to 12 centimeters, MLN is equal to 30 degrees, and LMN is equal to 90 degrees, right? So credit will be given for clearly drawn construction lines, right? So I'm going over here to my app, right? We add a page. Right. So we starting with LM, which is 12 centimeters, right? So in order to construct this 12 centimeter line, you need to go to a ruler, open your compass to 12 centimeters, right? I have a measure right here on my app, so this is 12 centimeters here, right? I ain't any 12, right? But this is right, 12 centimeters, right? So what I do is, what is the first point? Where we starting from? We starting from L. So I'm going to establish that point first, right? So let me put the point L. Put that in blue. So you put L here. Boom. L. Okay. I think come down there and make my lag, yes? Right. L. So what you're going to do, put your sharp point on L and you're going to draw a construction line. Bang. Right? Bang. So, next we're going to take our ruler, draw this line, bang. Right? Construction lines must be clearly shown. So this will be L to what? L to the?
L to M.
How long this line is?
12.
Is meters?
Centimeters.
Yeah, I think it's centimeters. Right, good. See, let me see what they're asking us for next. I feel I might have to drop this line. Because you're going to take a 30-degree angle now, then a 90-degree angle. Let me see if it go fit. So M to L to N. So what you say? M to L to N is equal to 30 degrees, mean that this angle is located by the middle letter, which is L. L. So we go in by L and construct a 30-degree angle. How do we do this? We come in here, boom to the bang. Right here, bang. Right? So you know you don't even have to adjust your compass, right? you're going to where you think around where 60 degrees will be. 60 degrees will be somewhere around here. Boom. Right? Ah, boy. That might be a little too big, boy. That might be a little too big. Hold on. Let me do what I show you all to do initially. Make it a little smaller. So you're going around between where the halfway point is and the full length in between there. You're putting an arc here, then you put another arc around where 60 degrees would be. Right? Then you're going to bring your sharp point, put it here, and then you're going to construct another line up here so that the two arcs intersect. Then I'm going to draw a line from L coming up here now, right? So I think I wouldn't catch it here now. I think I would need to drop my I might need to drop my thing, boy. Cause I don't think I'll catch it here. Nah. I gotta drop mine and all here. Let's see what I can do here. Hold on. Alright, that's all. I gotta pause it. Where we reach? Right, we're gonna construct MLN, right? So I think I'll show you all how it would look if we had if we leave the compass like this. So you can't leave the compass like this because you already have a point here to work with, right? So where do you go to around where 60 degrees will be? 60 degrees will be around here, right? Then you're going to put your sharp end here, right? And you're going to make an arc so that these two arcs intersect, right? Then you need to draw a line from here that's going up, right? You're just sending that line up, okay? Because it needs to intersect with the line that represents 90 degrees on the next side, right? So you're just going up with this line, right? So you're going up, scrolling down. So you're going up a little more. Right, boom. So that is that line. Now, what do we need to do next? We need to construct a 90-degree angle in this corner. I don't even think I'm there yet. I'll have to go a little.
So you had to draw a 60-degree angle.
Right, so this is 60. Oh my gosh. Sorry about that. Right, so we had to bisect this, so we didn't even need to draw this, right? So we bisected this. Let's bisect this angle. Very good, Andrew.
Excuse me, sir.
Yeah?
But for the 60,
So we're going to work with a smaller one here, just because when it's too big, it's a little hard to work with. So when you're working with this, right, you're trying to bisect the angle. So what do? 30 degrees will be somewhere in between here, right? So you're going to put another arc where you estimate 30 degrees to be. So 30 degrees will be somewhere around here. You're going to bring the sharp end here now. So I want to show you something, right? What's something? You'll see how my two arcs don't intersect. Watch. You'll see that? So what do you do in a case like this? You have to go back up here. Right, very good, Andrew. You go back up here and you have to extend this arc so that the two arcs can intersect. So I'm glad that happened there so that you all could see it. Now we're going to take the ruler, put it here, and we're going to draw a line from here going through here to reach where 90 degrees will be heading up. Because we're going to construct 90 degrees now, right? So, right, we good there. Okay? So, we're going to construct 90 degrees now. So, look at it. So, let's see if you observe here. It's not guess, eh? It's just an average. So, you're opening this compass to more than halfway of the line. Then, let me do this in red. You're going to draw an arc here. And you're going to draw an arc from around where 60 is, going all the way around to where you estimate 120 would be. Right? So you draw another arc here. Then you're going to put your sharp point here. And you're going to draw an arc up here. That arc must cut the arc that was there already. You're going to bring your sharp end here. And you're going to make an arc here again. Now, after making this arc, you're going to send this arc straight up to around where you know 90 degrees will be coming up. So 90 degrees will be coming up around here. You're going to take your sharp end, place it here, right? And then you're going to make another arc here. All right? So this point up here now, a line coming from M to this point here would be 90 degrees being formed here. So no matter how you do it, you would get 90 degrees, right? So I'm going to come up here now. Go shine red. I don't want red. Hold on. I want blue. That's right. We're coming up from here. Boom, bang, right? So that there would be 90 degrees being formed here. Boom. So this would be my triangle, right? It's a right angle triangle, a 90-degree triangle. Everybody good here? Ask the questions now, please. So I want to put in this 30 degrees here. Here's 30 degrees, right? Okay? So this is... So we go into... We have a triangle here. They give us the vertices. It showed in this diagram below, right? So on the ABC is mapped onto element by reflection on the in the x-axis, followed by a reflection in the y-axis, right? So reflected in the x-axis first. So if you're reflecting in the x-axis is here, so that image would look flipped, right? It's like you're flipping the object to the image would be underneath, right? So let me see how this would look. This is your mirror here. This is your mirror line here. Boom. Right? So you're going inside the mirror, right? 1, 1. This will be L. 1, 1. MN. This will be N because this is C. C becomes N, right? And B will be 1, 2, 3, 4. 1, 2, 3, 4. This will be M. So you can go ahead and draw that. Boom. Bang. And bang. Right? So you flip it down. Now you're going to reflect it in the y-axis. So this is now your new mirror line. So you have a new mirror here. The y-axis is your mirror line now, right? So you're going into this mirror now. Okay? So you're going 1 to the side. So this will become ABC is followed by wait. So same L. ABC is mapped onto element by reflection. Right. So this now becomes here. This will be L. N will be here, N, right? And then M would be here. Okay, so let's draw that triangle. Boom. Bang. Bang. Right. So this here is the complete reflection. Right? Raise your hand if you had this. Let me hear you know. The next part of the question saying, describe fully a single transformation that maps AB onto LM. What will map this from here to here? So it's like we're not including this. They want to know what would move ABC to straight to LMN. What would it be? It would be a what? Which one of the transformations, guys? Hello?
A rotation.
It would be a rotation, right? This triangle would come here and move to here. It's a rotation, right? But it's actually a rotation of 180 degrees, right? Which is the easiest rotation to find the center for. So let me just connect, let me connect these two corresponding points here. And we could connect these two corresponding points over here. Boom. And you will see that your center of rotation would be the origin, 0, 0. Right? So this is a rotation of 180 degrees. Now, once you're doing 180 degrees, you can do, well, this is anti-clockwise. But I'll just write it clockwise, right? So let us go clockwise, all right? Rather clockwise. So it's like you go clockwise, 180 degrees, right? clockwise 180 degrees. Origin is your center of rotation. So let me write that there. So the transformation is a rotation of 180 degrees about the origin. The origin is 0, 0 in a clockwise or anti-clockwise for 180 degrees, right? Right? Then they are asking us to state the 2 by 2 matrix for the transformation that maps ABC onto LMN, right? So if I check two coordinates, right, I'm going to write these coordinates in vector forms, right? So let me do A and L. So A would be positive 1, right, and positive 1. And then B would be negative 1, not B, sorry, L. L will be negative 1 and the same negative. This is L, this is M. So this will be negative 1, comma, negative 1 here also, right? So this 2 by 2 matrix, which could move positive 1 to negative 1 will actually be negative 1 0 0 negative 1, right? Okay, this will be my 2 by 2 matrix, which will transform AB onto BC. So therefore, the 2 by 2 matrix is negative 1 0 0 negative 1, right? All right, so we on to January 2019, 3A. Using a ruler, pencil, and pair of compasses, construct a right angle triangle ABC such that AB is 5 centimeters, ABC is 90, and BAC is 60 degrees, right? So I'll go in here now. So we started with AB as 5, right? So let's do AB as 5. I'm going to put A first. I'm going more to the base of the page here. So you have A. You're going to open your compass to 5. It's 5 centimeters, right? Put your sharpen on this point. Make an arc. Take your ruler now. Draw a line from A to the arc. That will measure 5 centimeters, right? This point here would be B. 5 centimeters, right? Now, we are going to construct a 90-degree angle and a 60-degree angle, but which one is going where? So, A to B to C is 90 degrees, meaning that my angle 90 degrees will be located at B. So, we are going at B and construct 90 degrees here. Put your sharpen here. Watch your tendency. You're going to make this, you're going a little more than the halfway point, right? So you put one arc here, and then you're going to put an arc from around 60 degrees going straight to where you think 120 would be. You're going to put your sharpen where the first arc and the line meet, and then you're going to draw another arc here. You're going to lift your compass, put that sharpen here, and then you're going to draw an arc around, this is the 120-degree point here, and you're coming all the way up to where you estimate 90 would be. So 90, say what is the idea? 90 would be going up. You come here, put your sharpen here, and you're going to put another arc here. So this would be my 90-degree point. This point here, I'm going to put it in red. Well, I'm going to highlight it. This point here would be 90 degrees. So I'm going to line up my ruler now. All right, let me line up this bad boy here, and I'm going to draw a line going straight through that, right? So we don't know where this line's stopping, so I'm just going to go straight up, right? As far up as I could go. Boom. Okay? Now, the next part of the question is we need to construct a 60-degree angle. Start going back here. 60 degrees is what we want to construct now. So you're using this compass. All right. We're going in red. You're going to draw an arc here. And then you're going to draw an arc at 60 degrees. So you're drawing a shorter arc around where you estimate 60 degrees to be. Then you're going to come here, place your sharpen here, and you're going to draw another arc so that those two arcs intersect. So what you could do now, you're going to draw a line coming from A straight up to meet that line up there. Right? Alright, boom. Right. So you come in here, boom. I draw it in red, but wait. Wrong line. You see how you could line up with the wrong thing? That's the wrong line or the wrong point I am lining up with there. Alright, so this will be 60 degrees here. Boom. So we're going up until we meet the 90-degree line up there. So we're going up, close, straight through my 60-degree point. My 60-degree point would have been right here. This is my 60-degree point here. Right? Everybody good there? That's how I construct that triangle, right? So here would be, here would be 60 degrees. And here would be 90 degrees, right? So this question came a little different, right? And it's good for you all to see it. They said the diagram below shows a right angle triangle with sides A units, B units, C units, right? So what letter represents the hypotenuse?
C.
C, right? And then B and A would be the other two sides. So if I was to belt out Pythagoras' theorem, what would I be belting out here? Hitman.
C squared is equal to A squared plus B squared.
This is the formula here, right? So if I want to express C in terms of A and B, I want C, not C squared. So what do I do with the square when I carry it there?
Square rooted to A and B.
Proper. So C would simply be equal to the square root of A squared plus B squared under the square root sign, right? That's all. One mark in the bag. Express A, B, and express in terms of A, B, and C an expression for sine theta plus cos theta, right? So we go into this. If I was to deal with sine theta, so and ka, right? Sine theta is equal to what?
Opposite over hypotenuse.
And cos theta would be equal to?
Adjacent over hypotenuse.
Proper. So, let me go. Opposite is what?
A.
Right? This is my opposite. Hypotenuse is what?
C.
And adjacent is?
B.
So let me go. We're going to write this out, right? So I can put when cos theta is equal to adjacent is B over hypotenuse. So this will be B over C. And sine theta is equal to opposite is A over C. So if I was to write an expression for sine theta plus cos theta, is like I'm adding these two things. Sine theta is A over C plus cos theta is B over C. When my denominators are the same, what can I do?
Add the numerators.
So this will be A plus B. So this is what sine theta plus cos theta is. Look at that. I hope all didn't overthink this, right? So we go in. That question done. So the last part of this question is that using the results in A part 1 and B, show that sine theta squared. Now sine theta squared would actually be equal to, I believe that was A over B.
A over C.
A over C. So that'll be A over C squared, which will be what? A squared over C squared. And then cos theta squared would be equal to
B over C.
B over C in brackets squared, which will be B squared over C squared, right? So therefore, sine theta squared plus cos theta squared would be equal to A squared over C squared plus B squared over C squared. When my denominators are the same, what do I do with the numerators? Ooh, what do I do with the numerators when my denominator is the same? Anybody? Hello? You just add them, that's only C. So C squared will be underneath here, and this will simply be A squared plus B squared. Alright? Now, they said to use the results from part A and B. Right? So if I look at part A, I could see from the top here that C squared is actually equal to A squared plus B squared. We're going to use this here. Alright? So C squared.
BC squared over C squared is equal
Right. So, but you need to put this there. When C squared is equal to A squared plus B squared, right? This implies that sine theta squared plus cos theta squared is equal to, instead of putting A squared plus B squared, I'm going to put C squared over C squared. C squared divided by C squared, or anything divided by itself will give me
1.
1. Proper. So this will be 1. Box to indicate that it was shown. Okay, so using a ruler, a pen, and a pair of compasses, construct the triangle ABC such that AB is 8, BAC is 30, sorry, and AC is 10. I'm going to start with AB as 8, right? So we come in here. AB is 8. Let me construct that bad boy there one time. Raise your hand if you did it. Many people did it. All right, I got a few people, man. So this is A, and it is 8 centimeters. It's 8 centimeters, right?
Yes, sir.
So,
Right. So remember, you have to open your compass to 8 centimeters. Go on your ruler and measure it, right? Measure the distance between the two pieces in the compass, and make sure it's 8. Put your sharp point here, right? You're going to draw an arc here. Then you're going to take your ruler and you're going to draw a line here, right? You see, I almost missed that way. I could have just turned it up a little bit, but anyway, I was going to show you all that, even if it has catchy corner here, you're good. So this is B, this is 8 centimeters. So we want to draw our what? We're going to draw a triangle, right? So we're going to do BAC as 30 centimeters, right? So BAC would be 30 centimeters, B to A to C. So that means our angle is coming where A is, right? B to A to C. So you could just, go a little more than halfway of the line, put one arc here, put one arc up here. Okay, now it's 30. So we need to bisect this. It's 30?
Yes, 30.
Right. So we need to bisect this angle of 60 degrees here because this is a 60-degree angle. So what I'll do, I'll make this slash here and I'll make this slash up here one time around where 30 degrees would be. Then I'll come here and I'll make another arc here so that these two arcs intersect. So this point here will be my 30-degree point, right? So let's draw a line now. So I come in from A, going, oh, I don't want that. So I'm coming from A, going towards this line here, right? So they said some line is, which line, wait. Which line is 10 centimeters?
The line going up.
The line I'm drawing right now is 10 centimeters, A to C. So I might have to, let me back up. Right. So I'm drawing this 10 centimeters. So what's going on here? I need to actually open this to 10 centimeters. Open your arc to 10 centimeters. Put it on A because that's where you're coming from. Draw an arc here in line with the 30. Woo. What's that, boy? I'm still getting a line there. Draw an arc in line with the 30. That's to indicate where you're stopping. So we stop in here. That's 10 centimeters, right? So we come in here now. Boom. Coming straight up to this line. That'll be 10 centimeters. Boom. Right? So this here would be C. And let me complete the people drawing now. So you just draw a line from B to C. You draw a line from here to here. Boom. And that completes my triangle. This is my construction of my triangle A, B, C, D. Proper thing, guys. Let me put this on the next side now. Snippet. Boom. Copy. All right. 4 marks in the bag. All right, we go now. So we just do this one time, right? It says state the coordinates of Q. What are the coordinates of Q here, my children? Hit me.
4,1.
4,1. Everybody seen this? Q would be 4 on the X and it lines up with 1 on the Y. Right? 4,1. This will be 4,1. The line PQ is mapped onto P prime Q prime by an enlargement of center 0. Now, once your center of enlargement is the origin, I could
multiply the scale factor by the coordinates.
multiply the scale factor by the coordinates. I just said it, right? So if your scale factor is 3, we're going to multiply all these bad boys by 3. So the coordinates of P would be, this would be 2, 2. So I'm going to multiply these coordinates by 3, because that's my scale factor. They want us to draw the line P prime, Q prime, right? So the coordinates of P prime, Q prime would be 4, 1. You're multiplying it by 3. So you will get 12, 3. And so 4, 1 maps onto this. And then 2, 2 maps onto 6, 6. So I'm going to do 6, 6, which is here. 6, 6, and then 12, 3. 12, 3 would be 3 is right here. Boom. So this will be from P to Q. Anyway, this thing. Wait. Right? So this will be P prime, and this will be Q prime. Talk to me. So the next part of the question is asking us, they said OPQ undergoes a reflection in the line y is equal to 0. The line y is equal to 0 is which axis?
The x-axis.
Proper. Proper. Y is equal to 0 is my x-axis. Right? So I'm going to reflect this in my x-axis, right? So we're reflecting it to O double prime, P double prime, Q double prime, and they want us to draw the triangle. So if I'm reflecting in the x-axis, this here would be my mirror line. Boom. This will be my mirror line, right? The x-axis will be my mirror line. So we go in. You're reflecting this Q down here. This is where Q double prime would be. P going 1, 2, and then 1, 2. This will be P double prime. O remains here. So O double prime will be right there. Right? It did not move. So let's draw the triangle. Start coming down here. Right, I 1. Die 2. And this is 3. Boom. So guys, we have come to the end